Welcome to Chemistry Properly Explained. I'm your host, J.M. Harris. In my 5+ decades of explaining chemical concepts, I was most famous for providing explanations to students who found it quite difficult to understand general chemistry. So in these lectures that I will be providing for free as my legacy, I hope you gain some insight to the chemical concepts. I will not approach the general chemistry course as is typical, and those who've known me for the last 50, 60 years understand that. My tutoring programs, which I started decades ago, have been copied, and in some colleges and universities actually were changed to departments, which provide tutoring not only for chemistry, but provided tutoring for physics, mathematics, and thus all STEM programs. It's been quite successful. I hope you enjoy it. To begin, chemistry as a study is an interaction of atoms, atoms and atoms, atoms and molecules and molecules. Now, the atoms to atoms is fairly straightforward because it's easily quantized because there's only about 100 elements, and so you can only have so many interactions. But when you introduce molecules, which can be huge from a molecular perspective and an atomic perspective, sometimes containing thousands of atoms just in one molecule, it becomes more complex. So as we approach this, we will tend to try to provide patterns. And as we quantize these with patterns, it'll make it more understandable for you. Today we're going to introduce the most important chemical to you and to your life of all the chemicals, and that's water. Now, you as an individual, again, I have a wide variety of people that are watching this, but I'll say the younger you are, the larger your water percentage in your body. It almost never is less than 50%. So when you're really young, your water percentage will be, greater than 50%. And when you're older, the percentage will be less. A number of things involved. The bone structure is primarily a metal calcium, and thus the larger the bones, the greater the quantity of calcium. And carbon complex molecules, which, provide the structure of your body, the tendons and leaders and muscles and ligaments and cells, are very complex carbon molecules. Thus, you're around 50% water. Water is a combination of hydrogen and oxygen. Now, it's not stressed, in my opinion, enough how much hydrogen there is in the universe. For instance, if you get up and go to the back wall and put a dot with a sharp pencil as one of your guidelines of all the elements except for hydrogen. And then as the other factor, you take the back wall and your whole neighborhood has the amount of hydrogen in the universe. That's a decent analogy. In other words, all of your neighborhood, quantity-wise, versus the tiny little dot. Now you say, well, okay, maybe that's all right if it's compared to different elements. No, that little dot represents all the mass and all the volume of all the other elements in the entire universe. That's how much hydrogen there is. Just an amazingly large amount. All those stars are glowing hydrogen, and lots of hydrogen. Now, water is a really unusual molecule. Fortunately for us, allows us to exist on this planet. Hydrogen is the lightest of all the elements and has one electron, and in its nucleus has one proton. So hydrogen's really readily understood. It has a nucleus with one proton in it, and around it has one electron. And again, the electron is indicated as an E with a little minus above it, and the proton is just a P. Now, hydrogen is the smallest, but it's also not really very common. If you were to analyze the planet Earth, the one element that is totally ignored and minimized is actually quite important, and that's nitrogen. The atmosphere contains 2/3 nitrogen. Now, you might say, why in the world does the universe come out that way? Nitrogen's important factor is it acts as a mollifying factor. In other words, explosions reach a maximum point because nitrogen is there to reduce their activity. Thus, when you start a fire, it doesn't burn up the whole world. Nitrogen's there to suppress it. And the amount of oxygen in the atmosphere, relatively speaking, is an approximate 20%. So we look at oxygen at 20% of the atmosphere. Hydrogen is 0.0005% of the atmosphere. So it's a very small quantity. You say, well, let's see, why is that? Hydrogen being very light is kind of hard for the atmosphere to trap. Again, gravity dictates everything on the planet. And nitrogen is moderately massive and is held on the atmospheric area by gravity. And oxygen, being relatively close to nitrogen as far as relative mass goes, is held for the same reason. So we've got 98% approximately of the entire atmosphere comprised of nitrogen, which acts as a mollifying or a reducing of activity, if you wish, agent, and hydrogen, or oxygen rather, which is 20%. And oxygen is quite important because obviously it allows the living of all of the animal life on the planet. And it also comprises portions of all the different molecular structures within you, within your body, from your hair to your skin to everything about you. So oxygen is quite important. Now, in nature, hydrogen occurs